Welcome to Online Solutions. We are on a mission to give you the best. Remember to subscribe. Thanks.
Let us look at the factors. Factors that affect the equilibrium. So there are three major factors that affect equilibrium. Number one is change of concentration. Number two is change of temperature. When temperature is changed, equilibrium will be affected. Another factor is pressure. What happens when pressure of a system which is at equilibrium is changed? Another factor we are going to look at is a catalyst. What effect does a catalyst has on the equilibrium? The effect of these factors that affect equilibrium was summarized by a scientist called Henry Louis Legendre, and then he came up with a principle that we call Legertre principle. How does Legertre's principle state? Legertre's principle states that when a change in conditions is applied to a system in equilibrium, the system moves so as to oppose the change. This is what it means. I have a system which is at equilibrium. I have two x there. I have 2x here. What happens when this system which is at equilibrium is disturbed? So if I add another egg here, the system will be disturbed. Therefore, it means it will move in such a way as to oppose the change I have made here. Therefore, equilibrium will shift to the right to oppose the change. Right? So more of this is going to be formed. If I make this system equilibrium balanced, then I introduce another one here. Then it means that I have disturbed the system which has been at equilibrium. Therefore, what will happen? Equilibrium will move in such a way as to oppose the change. So let us start with change in concentration of a system at equilibrium. What happens when a system which is at equilibrium, the concentration of the product and the reactants is changed? Let us consider a reaction A plus B which is at equilibrium, and it's going to give us C plus D. This system is at equilibrium. So what will happen if I remove A and the sum of B? Or what will happen when I add more A and more B? The concentration of A, meaning that I'm increasing the concentration of A or B. What will happen when you remove the concentration of C and D? So changing N of the components in a system which is at equilibrium will shift in such a way as to oppose the change. For example, I add more of A, put more A, increase the concentration of A. Equilibrium will shift to the right so as to oppose the change which has been made. What if I add more C? When you add more C, equilibrium will shift to the left to oppose the change which has been made. Pressure. How does pressure affect a system which is at equilibrium? First, remember that pressure will only affect a system that consists of gases only, because gases are compressible. They're the one which can be compressed by pressure. Therefore, what happens to a system that is at equilibrium when pressure is increased or decreased? Let us consider this general equation. We have 3A, which is a gas, plus B, which is a gas, is at equilibrium, forming 2C, which is a gas. This is a system which is at equilibrium. So, whenever we are talking about pressure, we consider the volume or the number of molecules. Remember this, the coefficients of A is 3, the coefficient of B is 1, the coefficient of C is 2. Therefore, it means the number of molecules on the left side is 3 plus 1, which is invisible here. So on the left side, we have 4. To the right side, which has 2. So this is what we call you can call it the volume. The volume. The volume on the right side is 2. The volume on the left side is 2. So, increasing pressure. If pressure, let me write this. If pressure of a system in equilibrium is increased. If pressure of a system in equilibrium is increased, then what happens? The system will favor the direction that has fewer molecules or volume. So, the system will move according to Reggetti's principle. Once you increase or you decrease pressure to a system that is equilibrium, equilibrium will shift in such a way as to oppose the change. Now, what happens in this system when pressure is increased? Pressure will shift to the direction that contains fewer number of molecules. Therefore, you do the mathematics here. This is 3A plus 1B. Therefore, 3 plus 1, the answer is 4. So on the left side, we have 4. On the right side, we have 2. Therefore, it means that equilibrium will shift to the right. When pressure is increased in this system, equilibrium will shift to the right. Similarly, when pressure is decreased, lowered in a system that is at equilibrium and it involves gases, when pressure is lowered, equilibrium will shift to the direction that has more molecules. That is the opposite of what we have written here. It will favor the direction that has more molecules. Let me give an example here. We have 3A plus, which is a gas, plus 2B, giving us 3C. Now we are decreasing pressure. What will happen when pressure in this system is decreased? Equilibrium will shift to the direction that has more molecules. So let us get the math. 3 plus 2, that is 5. We have 3. So where do we have more molecules? On the left side. It means if you decrease pressure in this system, equilibrium will shift from right to the left. That means backward reaction is going to be favored. Change in temperature. What will happen to a system which is at equilibrium when temperature is increased or decreased? First, you need to understand one thing. We need to know, is the reaction first exothermic or endothermic? Whenever the heat change is equal to a negative, that means that the reaction is exothermic. Exothermic. It means that the forward reaction is exothermic. For example, I have A plus B making C, and the heat change here equal to negative. Is negative. So it means that this forward reaction is exothermic because of this negative heat change here. The negative. The reaction is exothermic. Now we want to know what happens when temperature is raised. Temperature is raised and the reaction is exothermic. When temperature is raised in an exothermic reaction, the backward reaction, which is endothermic, is favored. Therefore, equilibrium will shift to the left. Equilibrium will shift to the left because the reaction already is exothermic. Increasing temperature will favor the direction, the backward direction, which is endothermic. So, in an exothermic reaction, if you lower temperature, if temperature is lowered, if temperature is lowered in an exothermic reaction, forward reaction is favored. It means that equilibrium will shift from left to the right. It means that equilibrium will shift to the right. A catalyst. What effect does a catalyst has to a system that is equilibrium? So you should know that a catalyst has no effect. A catalyst has no effect on the position of equilibrium. The only thing it does, it only changes the rate at which the equilibrium is attained, Therefore, a catalyst has no effect on the position of equilibrium. It will not change equilibrium to the left or to the right because it will only change or alter the rate at which equilibrium is going to be attained. Let us look at these questions. Explain the effect of increase in pressure on the following reactions. Look at this reaction. So we want to know what will happen when pressure is increased. So nitrogen is reacting with oxygen to form nitrogen 2 oxide. So what will pressure do when the pressure is increased? So first, calculate the number of molecules. This is 1 and this one. So on the left side, the volume is 2. On the right side, the volume is 2. Since the molecules on the left side and the molecules on the right side are equal, pressure will not affect this system which is at equilibrium. Therefore, equilibrium will not shift to the left, equilibrium will not shift, meaning that pressure has no effect on this reaction. Pressure has no effect on this reaction. Let us consider the reaction number 2. Hydrogen is reacting with carbon 2 to form methanol. So what does pressure do? First, get the number of molecules on the left. This is 2 plus 1 to give us 3. And on the right side, we have 1. So increasing pressure will favor the direction that has fewer. When you increase pressure, it will favor the direction that has fewer molecules or volumes. Therefore, equilibrium will shift to the right. Equilibrium will shift to the right. That means that more of methanol is going to be formed. The equilibrium will shift to the right. There's another one here. So calculate, look at this. This is 1 and this one is 1, 1. So this is 2. So when pressure is increased, what will happen? Equilibrium will shift to where we have fewer molecules. Therefore here, meaning that equilibrium will shift to the left. So equilibrium will shift to the left. It means that the backward reaction is going to be favored. Backward reaction is favored when pressure is increased in this system that is at equilibrium. Explain what would happen to the position of equilibrium in the following reactions if temperature is raised. If temperature is raised, so temperature is increased. If temperature is increased in this reaction, what will happen? First, identify the reaction is exothermic. Because the heat change is negative, therefore the reaction is exothermic. So if the reaction is exothermic and the temperature is raised, backward reaction is favored. So explain what will happen to the position of equilibrium. It means equilibrium will shift to the left. Equilibrium will shift to the left, meaning that endothermic reaction will occur. Reverse reaction, the backward reaction will be favored because the reaction is exothermic. When you increase temperature, backward reaction is favored, endothermic reaction is favored. Question number 2. Let us look at this. The reaction is endothermic. Since the reaction is endothermic, what happens when temperature is increased? When temperature is increased in an endothermic reaction, forward reaction is favored. Therefore, equilibrium will shift to the right. Equilibrium will shift to the right. More of nitrogen 2 is going to be formed in this reaction. So given the equation, this is an equation which has been given, manufacture of ammonia, the enthalpy change is negative 92 kilojoules per mole. Explain what happens to the position of equilibrium when more hydrogen is introduced into the system. So more hydrogen is introduced to the system. If more hydrogen is introduced to the system, it will disturb the system which is at equilibrium. Therefore, it has to move in such a way so as to oppose the addition. Therefore, how will it move? More of ammonia is going to be formed. Therefore, equilibrium will shift from left to the right. An increase in the concentration of hydrogen will shift this equilibrium to the right. Therefore, equilibrium will shift to the right. Equilibrium will shift to the right. So question 2. The pressure of the system is reduced. Now, pressure of the system is reduced. Let us look at the equation. What will happen when pressure is reduced? Because we are talking about pressure, look at the number of molecules. Here is 1 plus 3, which is 4. On the left side is 4, on the right side is 2. When pressure is increased, it is favors the direction that has fewer. Now pressure has been reduced in this equation. What will happen? If pressure is reduced, it will favor the direction that has more molecules. Therefore, equilibrium will shift to the left if pressure is reduced. Reducing pressure in this system, equilibrium will shift to the left, favoring the direction that has more volumes, more molecules. Therefore, equilibrium will shift to the left. Equilibrium will shift to the left. Temperature is raised. What will happen to the temperature is raised? We have seen that equation, that reaction is exothermic. Actually, the manufacture of ammonia, the reaction is exothermic because a lot of heat is produced. Therefore, increasing temperature will favor backward reaction. Therefore, reverse reaction will be favored. So if reverse reaction is favored, what happens to the system of equilibrium? So equilibrium shifts to the left. Equilibrium shifted to the left. Give the conditions which is likely to improve the yield of ammonia. The yield of ammonia. So let us look at so what would happen when pressure is increased, temperature is reduced? So how would we improve the yield, the production of ammonia here? First, because the reaction is exothermic, we need to reduce the temperature. Therefore, decrease. Number one condition is to decrease the temperature. When you decrease the temperature, you will favor forward reaction and the more of ammonia is going to be produced. Number one. Number two is you increase pressure. Increasing pressure will favor forward reaction. If forward reaction is increased, if forward reaction is favored, then more of nitrogen, more of ammonia is going to be formed. Therefore, increase pressure. Also, in concentration, you can increase the concentration of the reactants. Increasing the concentration of the reactants will favor forward reaction, and more of ammonia is going to be yield or manufactured. State and explain the effect of the following on equilibrium on the reaction indicated below. Increase in pressure in this reaction, increase in temperature in this reaction. So let us talk about pressure. What will happen to this system at equilibrium when pressure is increased? So pressure, whenever we are talking about pressure, always calculate the number of volume, the molecules. So on the left side is 1 plus 1, which is 2. On the right side is 2. So you see the number of molecules are the same, is equal. Therefore, pressure will not affect this system at equilibrium. So pressure has no effect on this system, because the number of molecules is the same or is equal. The number of molecules is equal, therefore it will not affect. What if